Alright, so basically along the same lines of what we did yesterday, just slightly different version of it. We're going to find the derivative implicitly, and then we're going to be finding the slope and then writing a line or equation for the line for the tangent and the normal. So from that. So number 18, x squared plus y squared equals 25, and we have the point 3, negative 4. So what would the derivative of this be?
2x plus 2y, y prime, equals 0.
Yep, and then move stuff around, so I'm just going to do this all in one step.
Equals negative 2x divided by 2y.
What's the... Yeah.
Negative x over y.
And then if you plug in the point, you end up getting negative 3 over negative 4, so that's just going to be 3/4, which is going to be your slope. So this is, I should say, this is your tangent slope. So for the tangent line, how would I set that up?
Y plus 4 equals 3/4. X minus 3. Distribute 3/4 through. And you can move the negative 4 at the same time.
Yep.
3/4 x minus 9/4.
And then you can go ahead and make the 4 when you move it over as being over 4 as well, so it'll just simplify it.
16/4.
Yep.
Y equals 3/4 x minus 25. 28. Wait, no.
No, you're right.
Oh,
Okay.
25.
Over 4. So this one is your tangent line. So then the normal line, what is the slope going to be of your normal line?
Negative 4/3.
Negative 4/3. So then your line, we're just replacing 3/4 with negative 4/3. That stuff canceled a lot nicer than that one. Do you feel like you need to see another one of those, or you feel good with that? Okay. Basically the same thing. It's just the writing the line, which you've been doing for 4 months now, basically.
Your laptop almost died.
I'm so reckless with like everything I have.
Yeah, the other day I had a flash drive in my laptop that had Kenny's sister gave me the flash drive with all of our wedding pictures on it.
So exciting.
And I put it in the computer, and I had it sitting like on like, we have like a couch that's like a middle thing in it that like, anyways, I had a couple things like stacked up on it that I had taken out of my backpack, and my laptop case was like under it, but it wasn't like level. And I look, and all of a sudden my laptop was going down, and I was like, oh no. And like there was nothing I could do to like save it. I was so scared it was gonna land and like the USB was gonna like break off in my computer or something. But fortunately it like somehow tumbled and landed so that that part was like straight up in the air. I was like,
Oh.
I almost lost it all. I was like, that's why I uploaded them to the cloud right after that.
Yeah.
It's like, we're not gonna risk that one. Because it would be my luck that would happen.
What'd you say? Not triggering, it's light touch.
Oh, I was like, what?
No, I heard
I meant-
Trevor, and I was
No.
like, okay.
I
That's
said
a really
triggering.
happy way to say that.
But it's light touch. Is it not?
Okay, seriously, people? Oh, you're
Why do I have these super out of order? Hmm. Oh, that's why they're out of order. Okay, we're gonna skip the second derivative implicit for the moment and come back to it. And we're like, just after we do some other problems. So we're gonna skip some problems. They're gonna be a little out of order, just FYI. I was trying to figure out why it was like that on my paper, and then I was like, oh, that's why. Okay, so these ones just say to find dy dx. So that's like basically what you're typically used to doing. So 32, if you have something like y is equal to x to the negative 3/5. It's saying find dy dx, which is just saying take a derivative like you've always done. And it's by that just telling you essentially find y prime. So take the derivative implicitly. So it'd be y prime or dy dx. They're just, yeah, anyways. I don't care which one you use. Is equal to, and then whatever the derivative of this side is. So what would that be?
Like 1 over something.
Well, so what do you normally do with the exponent? Where does it go?
In the front.
So negative 3/5 x, and then what do you normally do with the exponent then after you've taken the derivative?
Negative 8/5.
Yep.
That's it. I was thinking something.
Yeah, it looks like something that's going to be super like hard and complicated, and then it's super easy.
I was, for some reason, I was thinking like we had to undo the exponent.
Oh, yeah.
It's
Well, because when you said 1 over something, I was like, I mean, you could do it that way, I guess, but then you're going to have a quotient rule, and that's going to be irritating, so. All right, 40. Y equals 3 times 2x to the negative 1/2 plus 1 to the negative 1/3.
Oh my. He's like, oh.
Are you just attempting this one on your own for the moment?
yeah.
Okay, I was just wondering. That's fine. It was just like, are you still writing, or are you? Yeah, okay.
I just started doing it. I think I did it right.
What'd you do first?
The outside chain.
So that would give you negative.
2x to the negative 1/2 plus 1. And then it'd be times. Oh yeah. That's what it's like. I forgot about that completely.
Negative 4/3.
Yeah.
And then now you just need the derivative of the inside.
Yeah, which is gonna be like negative x minus 3/2.
So then your negatives are just going to cancel each other.
Can you do me a favor and like fix it for me really quick?
Move a pink yellow. We only put one camera.
And as far as I'm concerned, you can leave it like that. You don't need to move the negative exponents and stuff. You can just let it stay. All right. So we're going to go back and look at implicit differentiation, finding y prime and y double prime, so the first and second derivative. So these are a little longer just because of doing both. So the first derivative obviously is just going to stay the same. The second one is where it's going to get a little bit more interesting. I think 30 is a little easier than 28, so we're going to start with that one. So y squared plus 2y is equal to 2x plus 1.
Was the atom in seventh grade or what atom was that?
Yeah. Okay, I need to add some other stuff in that.
Two y prime plus 2y prime equals, it's just 2x.
Well, you're taking the derivative of 2x, so it would just be 2.
Yeah. Yeah.
So then you got, and you can take a 2 out of everything. So you're left with 1 over y plus 1.
I am so confused.
You just want things as simple as possible because taking that second derivative will get brutal if you don't have it simplified down as much as it can. So now I want to take the derivative again. So I would almost even consider rewriting this as y plus 1 to the negative 1. I think it'll make it a little bit easier to see the second derivative if you do it that way, instead of doing it as a quotient rule. So if I want to take the derivative again, what I'm going to do is now instead of it being y prime, now that I'm taking the derivative, I'm going to have y double prime. Or if you were going to write it the way that the book writes it, just so that you know what they're doing, they'll write d2y over dx2. That's how they're going to write it. But like I said, I like the double prime thing better. Just, it's cleaner in my opinion. So then what would the derivative of this y plus 1 to the negative 1 be?
Can you look at it again? I can do this.
Sorry, I like negative y plus 1 y prime plus. Oh yeah.
So then this is where it gets kind of interesting. You have a y prime in your problem now,
Yeah.
but y prime is equal to something. Y prime was equal to this. So we're actually going to take and we're going to plug in
That's
that for y prime.
okay.
So y double prime is equal to, and technically all of this is going to end up getting moved because this is negative y plus 1 to the negative 2 times y plus 1 to the negative 1. So it's just going to be negative 1 over, since these are the same, we can add their exponents together. So it'll be y plus 1 to the negative, or to the third, because we moved it to the bottom. Now.
Okay, you're good.
I will tell you this one's gonna be kind of long, so
It's on the text.
okay. That's probably a good place to start because it's just mine is like a half a page, but it's like all over the place. So
Makes sense.
all right, so let me focus this back.
Let's. I'll walk through this one.
I don't know where you stopped.
No, I am actually right there, which is the same thing I was doing.
So you, okay.
So I'm at y prime equals negative x to the negative 1/3
Okay.
over y to the negative 1/3.
So then, just to make your life easier, both are negative exponents, meaning we can flip them.
And then
So they'll become positive, and since it's, we may or may not end up using it this way, we may end up rewriting it, but since they're both the same exponent, we can also, like, throw the exponent outside of the whole thing. So we would end up with y prime is equal to negative y over x to the 1/3. And just because there's going to be so much going on, I'm going to circle that.
And then we take the double prime.
Yeah, so now we're going to take the derivative again.
So then that's y over 9. That's a quotient inside of J rule.
Mm-hmm.
So it's 1/3 negative y.
Make sure you keep that negative out front. I don't know if you said that
That's
or
out
not.
front.
Well, there was a negative out front of the whole thing.
I
So
thought it
just,
was y.
I mean, technically it doesn't really matter, but it'll make your life easier if you leave it out outside, and then we'll just multiply it by the whole thing.
To the negative 2/3. Y prime. This is y prime. Oh wait, no.
quotient rule.
Yeah.
She's not on the roster at all. And I swear she's. She's so good.
Who?
Sophia Baker. Wasn't she on your team?
Nope,
She left.
they left. But go ahead and put them in though.
Did Bella leave too?
Did you not put her in?
No, well, no, because it's not on the
Oh.
roster.
Yeah, they withdrew not that long ago. If we have a picture for somebody, we're gonna use it. Because that means they were here long enough to have gotten their picture taken. If we don't know their name,
But what if we don't know what class they were in?
what do you mean? Are like all the sixth graders like lumped together?
All the kindergartners are. And there's 2 that aren't on the roster.
They're not on either roster. I guess just make a note of them and we may have to go fix it, or we may just add them in at the end or something. Well, we'll have to move them, but. Nelcher, are you working through this jumbled mess at the moment? Okay. So since the negative, you have the negative out front of the 1/3, and you're gonna have a negative when you plug in the y prime, your negatives will just go away. So we can just get rid of it and make your life a little easier. And I will tell you, if you get to this point on a test or a quiz and you want to leave it, like, it's okay to stop here. Like, you can go farther than this, but, like, if you left it there, like, I'd be okay with it.
Okay. And then
Because basically, at this point, this stuff is going to stay for right now. Then over here, you're going to end up with y to the 1/3 times, this is x to the 1/3 on the bottom and a 1 up here. So you can subtract the 1/3 from the 1 to give you x to the 2/3 minus y over x squared.
I thought that was a question or something. Or a product.
Well, we had already taken the derivative. This is just plugging it back in.
Okay. That's what.
Oh my god.
Yeah, yeah. I
Is
thought
there
it was.
another one?
Yes.
So then,
I don't know this guy's name.
okay. So then what you can do now is
Easy.
hold on. This is where it gets a little hairy. So here, let me rewrite this all as one big thing at the moment. So this is going to be x to the 2/3 times x to the 2/3 times y to the 1/3 minus y. Well, I'm gonna still write it, but I've got to do something first, because, hold on. Because technically, this is all being multiplied by this.
Yeah.
So, yeah. But this we can also treat as like 1/3 and then times x to the 2/3 over y to the 2/3. So that when it's being multiplied, like this stuff's all going to be on the bottom and that stuff's all on the top. So multiplying it by the first piece. Here, I'm going to switch colors because I suspect I'm going to end up having a mistake here in a second. The first piece, that's going to give me y to the 1/3 x to the 4/3 minus x to the 2/3 y all over x squared y to the 2/3. Whoa, what just happened? That was really weird.
Oh my god.
Did you multiply the 1/3 through all the way?
Oh, I forgot the 3 on the bottom. The 1, yes, but the 3 I forgot about, but it's just hanging out on the bottom.
How do you multiply by?
This is very weird.
Wait, don't you multiply?
Okay. We did it.
This is why I said you can just leave it at the green circle if you want, because I would not expect you to do this. This is just obnoxious. You can take...
How did you multiply it?
I just distribute it. So, like, I did... Because the 1 I don't really have to worry about. So, x to the 2/3, I multiplied by this first part. So, that gave me the x to the 4/3 times y to the 1/3, and then minus x to the 2/3 y. And then on the bottom, all this was just being multiplied.
Oh, okay.
So that's how I did the
For
bottom.
some reason I thought you had to multiply the whole fraction to the top.
So if I can just multiply the top to this, that's 2, 2.
Because then I can take out from the top I can take out an x to the 2/3 and a y to the 1/3 and be left with x to the 2/3 minus y to the 2/3. Then you can move this stuff to the bottom by subtracting it. So then this gives me on the bottom, oh, hold on the top, x to the 2/3 minus y to the 2/3 over, move it to the bottom, 3 times, okay, so I have x squared, which is equal to, I need it over 3, so x to the 6/3 minus the 2/3, so x to the 4/3. What?
What did you do to the bottom?
I'm moving these two things to the bottom by subtracting exponents. So I had an x squared on the bottom, so I was just trying to rewrite it to be able to subtract it, since this is a,
Oh, no, you can simplify it.
yeah, since it's a fraction exponent.
Got it.
So then I had y to the 2/3 minus 1/3, so that's just going to be 1/3. Oh, wait a second. Oh. Hold on, I need to go back up for a second. Remember how up here I was like, oh, there's a negative in front of, there's really a negative there. I forgot that because there's also a negative here. I can still get rid of the negatives, but I've actually got to get rid of both. I've got to like pull a negative out of both pieces. Because everything was being like, this whole thing was being multiplied by that, meaning to actually take this negative away, I've got to also take this one away, which is going to make it so that this is positive, which would have probably helped the whole situation along the way.
I don't even know where that was in my notes.
Up like 3 or 4 steps. It was right after we plugged in y prime is where I did that. Actually, yeah, because I plugged in y prime and y prime had a negative.
Yeah.
And I was like, oh, just get rid of it because you can, but I forgot. This is why parentheses are so important.
Well, I had them in parentheses, like.
Yeah, so I didn't, and that's why I was like, oh, I'm just multiplying. But like visual, I don't know. For me, visually, I have to actually see the parentheses, but I didn't think to put it.
I just didn't do it.
Had I done it, it would have solved a lot of our problems, and it probably wouldn't be taking me so long.
So it's plus and then everything's.
So then all of these where we had minus y going down are now plus y.
Plus Y.
Yeah. And then like when you got to here where I switched to red, it'd be plus x to the 2/3 y. Because it was negative because I had the y with being negative, but that's not. That's plus. This is plus. Now, look at this right here.
Yeah.
X to the 2/3 plus y to the 2/3.
Yeah.
Okay, go all the way back up to where we started. X to the 2/3 plus y to the 2/3 is equal to 1. So I can now replace that as 1 over 3x to the 4/3 y to the 1/3. And that's the final answer that they wanted you to have. However, like I said, had you gotten to what that big thing that I circled in green was, I would have accepted that. But it technically wants it simplified all the way. So the other problems that I would say for you to look at, and I'll like give you tomorrow to work on this stuff because I don't want to just like keep going until you've had time to like do these problems. I'm gonna add those to what I gave you yesterday, which is somewhere in my notes. I think. Yesterday it was 1, 7, 9, and 13, so. Anyways, but those would be good problems to look at.
So, a lot of homework.
Yeah, and I mean, the thing is you don't necessarily need to do every single problem. I'll be honest with you. But I've tried to give you an easier one and a harder one for each of the types of things that we did. But like with the tangent and the normal line, you may say, I get this, I just need to do one of them. But with like these ones, like we just did, the second derivative, you may want to do both of them. Just to like get the process.
What is this, 4.2?
This is 4.2, yeah.